Hello everybody, welcome to another stream. How we doing? Hey there, my Var, good to see you. Damn, you go to bed soon. Be at sea all day. Sailing. Oh, cool, nice. Is that a thing you do often, or is it just a one-off thing you're doing? That's cool. But yeah, just do the quick intro. So, last stream we basically wrapped up on the fractal noise shader thing that was doing to basically generate materials in shader code. And we're going to be exposing we'll be exposing that in the editor, so you'll be able to make materials for the game really easy inside the game. Now, there's a couple of things I raised at the end of last stream to do with the material system that I might want to investigate before we move on to be making the sort of material builder side of things. And that was like, do I want to increase the limit of 1,024 materials loaded at once? And I've thought about it off stream, and it's not a problem for now. So if we need to cross that bridge, and if it is a problem, we'll obviously fix it then. There's another thing that I was looking into, which was would we want to take a material which is comprised of the albedo emissive, roughness, metalness, and the normal map? Would we want to take each of those components and be able to mix and match them with other materials and make another material from that? And again, it's a thing that I don't think we need now. And the system I've designed works really nice if we just have one material file with all of the textures just in there, and they're unique for each material. Mix and matching them doesn't seem to make too much sense for this game. So again, if I need it, I'll do it later. So I then thought about, is there anything I need to do before we get onto the material builder? And that is the title of this video, which is we didn't really do a normal map properly in that sort of fractal noise shader thing. So we're going to automatically generate one from a height map, but it's going to be slightly different because it's for a sphere and not for a textured mesh, right? We probably want to add a way to scale and offset every material property, like the emissive or the roughness or something like this. So we can make something like appear like it's glowing and changing its glowy, how much it is glowing, or it's pulsing. Yes, that's all I'm saying here is we want to be able to affect a material channel as a whole at runtime. And fade in a roughness layer, for instance, or make emissive pulse. And then the final one is combine emissive color and emissive strength into a single texture. And then I was looking into block compressed. I said I didn't really want to do block compressed textures because it would be more work. But the benefit of doing it right away is it means that the performance that we're measuring, it would be more performant if we sample from block compressed textures, because there's less memory that's being accessed, although it will come with some artifacts. So we want a way to be able to turn this off and obviously have it on. But yeah, there's a good way to generate, like I generate these materials on the GPU, so I want to have a way to block compress them on the GPU. And there is an open source single header here which block compresses BC1, 2, 3, 4, and 5. And for people who know about BC, the block compressed formats, BC1 and BC3, is that right? I get so confused with these things. There's BC1 and BC4 are basically the only, I'm not going to bother explaining it. There's plenty of resources online if you want to know what block compressed format is, but they're all kind of similar. BC1, 2, 3, 4, and 5. They're all kind of made from each other in a way. They work in similar ways. They just work for different numbers of channels and things like this. So this is like 500 lines, 600 lines of code we can just port over, does the job. And there's probably a better compressor out there, but this will just hopefully be good enough for now. And if we need to do a better job, we can always bring it back to CPU and use another one from another library, or try and do a better job on the GPU later on. if that becomes a problem. So this would be good to get going. I think this will be the stuff I want to work on for the next week and a bit of streams. So today working on the normal map. Yeah, doing training to get licenses. Amazing. Cool. So you do like drive boats and stuff. Nice. Interesting. How long have you been doing that for? Is this something new you've been learning? So this is what a normal map will look like for a you know, if you use meshes, you basically generate a normal map, and the vectors are pointing in tangent space, meaning you can kind of, another way of saying it would be like the surface, the space of the surface. So even if the surface sort of bends around like this, imagine it's made up of a bunch of triangles, and imagine if so it's blue, meaning the Z component, right? Because RGB, right? X, Y, Z. Blue means it's pointing sort of towards outside the screen, right? And if it's just always blue, as in pointing down the Z, it will always point outside the object like this, right? Even if the object actually moves, because in tangent space, it's essentially as if it's sort of just flat like that, isn't it? In a sense, right? That's what tangent space is, and you'll basically take sometimes your lights into tangent space, or you'll take your normal and bring it back out into world space. But for a sphere, it's as, you know, I've got a slightly different setup going on here. So we're not really going to be doing this style of normal mapping, because the way we map our textures is we use the octahedral mapping, and we need to be able to take our normal and then turn it back into a local space, and all in the local space of the sphere. So all we have to do is take a height map, right, which is in this octahedral map layout, and turn it back, and generate a normal based on the height map, right? And then, yeah, generate a normal map from that basically. So the way you got to think about it, say you have this sphere, and then, so I think let's just describe how it would be normally. So how you'd normally do it is if you have a height map, you would basically take, the way you generate it is you take the neighboring pixels. So this is one you want to generate the height for. You take the two neighboring pixels, and you basically do like a how would you do it? You take like a difference of the x and a difference of the y, and then you probably do a cross product as well. Is that what they do? Let's have a look. So shader toy, normal map from height. So yes, again, the difference in height across the x, difference in height across the y, and then it's negating the vector and scaling it in some way. Oh no, that's the standard, right? Okay, this is doing it with the texture sample. Right, so it's got the original height, the neighboring height to the right, neighboring height up or down, whichever way around it is. It produces a coordinate for that, and then takes some difference, right? And then that apparently generates a normal from it. But yeah, ours is not going to work that way. So we describe how the problem we've got to solve is for a sphere. You can imagine that for every normal, whether to a pixel, basically, we've essentially got a height along this normalized vector, right? So if we get the neighboring pixel height and vector, and the neighboring pixel in the other along the other axes, right? And then we could basically scale this these normalized vectors along the height reported at this pixel and that pixel, yeah. And then we can, so then say if that scales these down to here, like that. So one will go up like that, the other one, your other one will be here, and you'll be there like this. You could then use the you then do a subtract and get a vector towards these, right? Each of these two other points, then do the cross product, and that should get you the normal. Right, and then we'd have to encode that back out into the octahedral map. Now, getting these neighboring cells is going to be a bit of an issue with the octahedral map. We'll go into that in a little bit more detail. But let's just get started up on run the basic code for it, and then we'll fix the problems with it. Pretty nicely tool to estimate TBN and GPU without having to put it in the vertex. Oh, is there? Yeah, I didn't have to work out TBN luckily enough in this case. But yeah. Yeah, I don't really know so much about the yeah, you still have to put it in the vertex though, won't you? I wonder. Hey Lupo, yeah, I'm not doing bad, thank you. Not doing bad, just you know, a little bit tired. I think of the best of sleeps, but I'm doing okay, thank you. How's your day been? What you been up to? Yeah. So we're going to be making, so typically, right, we generate, there'll basically be a function that you can call in, so when you have these sort of procedural material shaders, which you can do whatever you want in, and then expose to properties, what you can do is have multiple passes. That's one of the things you can do. So we're gonna, so quite a lot of them are probably gonna have some form of like, hey, I'll generate my albedo emissive, roughness and metalness, and a height. And then most of them will probably have a second pass where they go over the height map and then just generate the normal map from that. So we're going to have a function which will take in a height map and generate a normal map based on a pixel coordinate. Can I get some dimensions as well? Yeah, get some dims. Good. So we'll have a way to say octahedral normal map from height map, something like that. And we'll take in a coordinate that's going to be sampling from, or passing the dimensions of the texture. And then we obviously need we'll obviously need the height map. So read-only texture. All right. Okay. So a lot of the second passes of shaders that people will manually write will simply just call this function, get the normal. So ucoord bc dims for the texture dims that we're rendering, and the height map. And then all it'll do is output. So we've got to get the normal in octahedral map normal basically. So it'd be a pack. Something like this. Do I need a UV? I'll probably need a UV here, I think. We'll see. Do I need a UV? No, I just need to... No, I don't need UV. Yeah, that's how simple the shader will most likely be. Maybe we could just have a default shader that just does this, right? But we'll see. If you're curious, I've posted the code I normally use in the graphics channel on Discord. It is not useful for you, but I'm interested. Interesting. I typically use different parallax displacement mapping. Not perfect, but it works. Okay. You know, it'd be good to know, because it's something I'm not really that aware about. So thank you so much for posting that. Appreciate it. I'll take a look after the stream. That'll be handy. Because I know that you basically encode it into your vertices, but I don't know how it gets there. But yeah, you typically have to make sure you generate your DUDVs. Yeah. They have to be kind of... Anyway. I won't say any more because I literally don't know much about it. Okay, so now this is where we need to get the neighboring pixels. So in an octahedral map, it is not very straightforward to get it, but we can just start off with something very... Let's just write the initial code that I expect it to be. So the way I expect this to work is we basically go into the height map and we do like a load. Or let's say we basically need to work out some neighbor x coordinate, which will just be something to do with ucoord.x. Let's just say it's like this, but it's not. We'll get to why that is in a minute. Neighboring y coordinate. Then what we're trying to do is load out a height. So load texture 8 unorm 2D 8 unorm. So height map nx coordinate and then ny coordinate. So with these two heights, we should be able to take the... we might need the normal map as well. Wait, not the normal map. Oh, we'll need the UV. And then you go from UV. into, is that right? Yeah, we need to work out the UVs for those. Right, rather than nx and ny, we'll just do x, y. What am I trying to say? Okay, hx, hy for height. Yeah, this is better. Then, right, we need to take the x coord. UV neighbor along the x, UV neighbor along the y. Then we need to unpack the octahedral UV and get us their normals. So go back to that diagram in just a sec. Then from here, we can scale up the normals. You normally calculate on the CPU in your asset file that contains the tangent. Right, Blender for example, but they should cheat and approximate it on the GPU without the HDR. Amazing. That's pretty cool. Right, so basically, right, we've got this pixel here, it has a height, and we're getting its neighboring one along the x, neighboring one along the y. And we've got their heights, and now we've got their normals, right? That's all we've done here. This is getting their normals, or these vectors basically, right? And what their heights as well. So to generate the height map, the way I'm thinking about doing it is we simply just scale the normalized vector by the height, right? And then when we have, now we have three vectors, right? Well, it's only just two, just let me do this. Right, I need to do a, there we go. So we've got three heights, three normals, and now all we have to do is get, so imagine this height could have been scaled down to here, right? And then this height could have been scaled down to there, this one could have been scaled to up there or something like that. So now what you need to do is do a subtract and draw an arrow towards this one, and do a subtract and draw an arrow towards that one. And those can be two of our basis vectors, and then we do a cross product to get the normal. And that's the way I think we can do it for the sphere. So if we get Vx, which would be a subtract between, so going towards the neighboring x normal from the current pixel one, then going towards the neighboring y one, then we finally produce the normal by doing a cross product between. Now I do think we've got to normalize these. Is it cross? Does it keep the normalized? Yeah, I don't know. normalizing after a cross. Even if one of the inputs is not normalized, then we always normalize the result of cross product. Yeah, the same thing can be done with derivative. Yeah, it's same. It's a similar sort of thing, right? You can do it at, there was that shaded toy example. But then in tangent space, he did it with derivatives here, right? The ddx, ddy. So one of them is ddx, ddy. The other one is doing the sampling approach. But yeah, I would expect them to be the same, to be honest. But the code does look slightly different. Yeah, I wouldn't take that as... Cross product, and if it requires normalization when used to find perpendicular axes. I just want a yes/no answer, I don't care. We can just normalize it, it doesn't matter. Right, so I think these all need to be normalized. Let's just do it anyway. And then... Right. And that should be the code. Okay, but it's got one problem. So the issue is that these are actually not the neighboring coordinates in octahedral mapping space. So you've got a few problems. One, you've got edges. If I can pull up a... Wait a minute, let me go to the... Can I run the... There's an octahedral map debug that I can run. Material 0? Yeah, material 0 to the octahedral map, so we can see that in the texture viewer. Okay, so we're seeing the octahedral map now, so it's just for every single sort of, I think you call it an octant, yeah, 1/8 of the sphere is being mapped into, let's go to the texture viewer, let's go to the texture that gets generated. This one. Yes, so as you can tell, 1/8 is one of these triangles, right? So there's the yellow one. Now, here's the thing. It's not very standard, like, oh, where's the purple? Is that at the bottom or something? It's the way it's rotated, isn't it? Right, let's do it this way around. Yeah. So you see here we've got the green and the yellow. Well, if you are to take your mouse, or where the mouse is, and if I was to go across here along the x-axis, right, and go across this area here, you see that there is an edge, right, between the red, or sorry, between the green and the yellow. So you might expect, right, oh, that edge is here, clearly. Well, that answer is wrong. Is it wrong? Oh, I get so confused with this layout. Yeah, it's got to figure out where it is. Yeah, so we saw it with this sort of black and red one. We went for the black and red one. So that's at the bottom now, apparently. It's where it used to be at the top. So we did this across here. It wouldn't actually go across there and then appear over here. It actually went downwards, right? And then reappeared over here and came up here, right? So it's a very sort of... The way it's unwrapped is a bit strange. So we can work that out with maths. It's just we've got to obviously do it manually. We can't rely on it just being a very simple mirror across there. So what I might do to debug this is let's like put a bit of code in so we can actually visualize what's going on. And then once we know all of how it works, then we can write the code that it actually finds the correct neighboring ones. Now, something to be aware about is we can already see that no, wrong side. Top side. Yeah, so you see in the middle here, this is where they will meet in the middle. So technically, like you can already tell, if you want a vector which goes up, right, the neighboring up one, that is, or along this sort of, like it's diagonal, right? So if you followed it diagonally, you will go through. Yeah, maybe that's all we need to do. Maybe we just need to go diagonally. So we went diagonally. Oh, but there's the black one. So black, blue, cyan, yellow. Right, blue. Yeah, it doesn't work, does it? Oh my days. Yeah, so this here, this point here. Yeah, so it seems like if we have a coordinate that goes this way, and comes up here, is actually, if we keep going up, it will come down like that. Right? Yeah. And then it's going to go in between these two, I think. And where the hell will it come out? So this is where we're going to get like a little point, and we'll draw it on the... We'll like put our mouse cursor over and we'll be able to see it in texture space. Cool, so let's get writing that code. So I've done this code in the past, if you remember, when we was trying to debug something else with the octahedral map. And then we'll be able to get better neighboring pixel coordinates. So all we need to do is when we do the renderer, so I think that'll be in the shading, I think it's just called shade, because I'm currently doing the visibility buffer approach, which I want to go back to the tiled based one. I got both code, I've just not bothered on, turning the other one back on. So I think we have the local space, redirection, no. Local space, normal. Right, how did we do it before? So when it was rendering, I wanted to store in a global, hey, my mouse is hovering over this. Yeah. So we go if is mouse at this coordinate, and we've got a hit here, right? Then what we're going to do is store in the globals. We're going to store a hit normal local space. And with that hit normal local space, we can basically gauge where it is in the texture and then make that pixel red, I think. Something like that. Yeah. Or make a set of pixels red. Yeah, based on a radius. Yeah. Should be quite easy. So we'll just put like debug. Right. So in internal shed, if we go to globals, I just find a place for it here. Now all we need to do in that generate material is go, okay, if this is a compute shader you've been working on. Yeah, no, yeah, I only do compute shaders for this project. So the whole renderer is pure compute. So it simplifies the whole renderer. We don't have any sort of, it really minimizes the amount of the Vulkan abstraction that we use when you just launch compute and that's it. But it obviously has some downsides, like, you know, the GPU is really designed for triangles. So you end up basically putting stuff into screen tiles and doing like a binning approach for a lot of things. Basically, good way to go. Yeah. So it's just mainly a bit of a challenge to see what you can do without the using the triangle rasterizer. And yeah, you can still do quite a lot with it. It's just you've not quite got the flexibility of just being able to rasterize triangle shaped areas over a screen efficiently. But yeah. Yeah. It'd be cool if we just had if the GPU was like purely programmable, and this sort of gets you closer to that sort of dream in a way, which is kind of cool. But yeah, I'm not the first person to do this, by the way. There's plenty of other people doing it, I think. And if you take a look at most games these days, I'm pretty sure like probably 90% of their shaders, or even a higher number actually, are compute. They just use, pixel shaders and such just to draw meshes to the screen. Quite a lot of the time, I would think. Yeah, it's not equal to 0. We want to say, given our current normal, if we do the dot product between the two, do we have something which is greater than 0.9? Then if so, albedo.rgb is equal to red. Right, so we get a nice red dot, and oh wait, we need to make sure that we run this every single frame. So it's going to tank the performance, but it doesn't matter. Well, no, it'd be alright, because we're just in a very quick... Okay, it's a bit too big, but we've got the debug working, look at it. Wahoo! So you can see it in the... oh, no. Let's shrink that down a bit. So this is 0.99. Theoretically, you can implement a scanline triangle. Shit. Well, yeah, that's the thing. You can do it. Like, you know, in Nanite, they rasterize their triangles, their subpixel triangles, or triangles which are like around about a pixel or two or less in size. They rasterize that purely in compute, right? And it is faster than hardware. And that's the reason why they do that. But if you just obviously rasterize regular triangles in compute, you're going to do a worse job. Right. So this is me going across this boundary here. You can see that sort of the way it just goes bing. So what's interesting is that it's not even... yeah, oh it is. So it goes across the y, then x, even though I'm just going across the x-axis, right? So that just, I'm just moving up there like that, right? Okay. Rightio. So let's go near the top and see if our... so let's freeze the camera. Right, so I'm just going to brush across this boundary here and go into the yellow. Right, I need to move that. Right. So as I expected, right, it does go and reflects down. I remember when I said it would go across here, then go down like that. So it does do that, right? Cool. So then let's follow around. That is against the red boundary. Let's just take a look. Let's go down. Crap, it's going into red, isn't it? For crying out loud. Let's go around the other side. Blue into dark blue. Crying out loud. Right, and then it reaches the bottom and does... that is so weird. So what we're saying is, if we get something that goes down the middle, in between... this is so weird. In between all of them and just goes round. What it follows this sort of line. It goes diagonally across here, kind of thing. Reflects around there like that. Goes up around here like this. Wait a minute. The middle there. Ends up round here, comes down and goes round again. Oh, it's a bit weird, isn't it? Oh wait, goes in the middle there. There. Middle here. Right, okay, it's bananas. Right, so trying to find a way that we can easily get like basically a neighboring... lost my sphere now. A neighboring pixel along the x and y kind of thing. Now I don't know if we're looking for spherical coordinates per se. We could just take a neighbor along. Why don't I just take the neighbor? Theoretically, okay, algorithm, yep. Maybe a for loop and a shader drawing a straight line. Yeah, we could do. But yeah, I don't really need to do much, so this is kind of good enough. So yeah, going across that boundary to there. Oh, that's interesting. So that whole line goes across sort of here and here. And I guess it does a similar thing. Did I break? Oh, I took a screenshot, damn it. Alright. We're back. Right, then I go across the edges again. Right, interesting. Okay. So, in terms of like getting... Right, so if we follow the... Right, so it seems like you can do a diagonal across this way. Okay. So going from here to here is like going over like that, okay? And then... you can go around here probably and do the same thing. Or has it got a red? Maybe I should have made it invert. But yeah, it's the same sort of thing. But it goes around here like this. Yeah. Okay, so maybe we can leverage that then. So there is a... so going diagonally across here... Quite loud, so going diagonally across here is kind of straight line. So let's see if there's a diagonal across. So then like, wait, let's, yellow, green. Yeah, so as to go perpendicular from there. Right. Okay. Yeah, I guess it's a similar thing, right? You can go sort of through the middle here, like that. Now go through the middle. And you can follow that around and you end up at the black, basically. Right. So I wonder if you could do diagonals and would that be enough, basically? Yeah, we did the diagonals. But the issue is... Right, so... Okay, so I think what we can do is we can take, given a pixel on this octahedral map in texture space, get a vector to the center, do a rotate with the vector 90 degrees, and yeah, let's leave this debug draw in for now. So I reckon the way we can do it is we draw a vector to the center from a pixel, just go towards the center. Then you want to get that's one of your axes. And the other axis will be a perpendicular one. And it don't ever really matters which one it is, but let's say I want it to go right. So that would be, so you're like a positive y in that case. So you would, you're positive y, positive x. So you need to make a negative y. Yeah, negate the x when you swap it. Okay. So let's just write that out quickly. So I want to get that sort of perpendicular one. That would be c dot y minus c dot x when we swap it. Yeah. And that'll get us the sort of right hand side one. Okay, so that would be the, you want to get the right, okay, so what we want to try and do is point towards the middle from, so given a point, draw a vector towards the middle, get the sign, isn't it? So I guess we'll call that the sort of the y coordinate maybe. So it'd be a y coord will be sine of it'd be the sine of we need to get the center pixel coordinate. So I guess we're going to handle like, so if we did it in floats, it would then mean that we could offset it by 0.5 and therefore we will guarantee that it always have a, it will not be 0, right? And then you normalize it. Yeah, probably. So subtract towards the center. And that'll be like a dims dot x divided by 2. And then you probably offset by 0.5 or something like that. Such that So that's the center. Then you need your sort of coordinate in floating point. So the way we typically do that is we would do this sort of add 0.5 as well. Yep. And now with this, we can get a vector going towards the center. So that'll just be a subtract towards the center from the floating point coordinate. Then if we get the sine of that, that will give us a -1 or 1. It doesn't give us 0, it just gives -1 or 1. And that will basically just give us a direction towards it always. So over here, it'll give us a direction that way. Over here, direction that way. But in -1 or 1s. So then we want to probably put that down back into a there you do the sine and then integer cast. Okay. Then the x diff is basically the y coord diff, just a perpendicular version of that. So if we're down here and we've got one pointing towards the middle, it'd be the one to the right here like that. If we've got one going that way, it'd be one to the right like that. Yeah. Cool. So now with this, we should be able to basically take this and go plus that dot x and then plus that dot y. And then, the y coordinate one above is exactly this. Oh crap, I did it wrong. Right, so that's the x1 and this is the y1. Right. So we're most of the way there now by figuring out that stuff, right? But the next thing is that we've got to deal with is what's known as... Oh wait, we might not have to deal with them anymore. This would be amazing. Since we're always pointing towards the middle, we might have to still worry about it. So the problem is the edge boundaries, the way they wrap. They don't wrap well. They wrap in a very weird way, and we'll have to handle that manually, but we might not have to. So let's just have a bit of a think. Let's get the octahedral map up. Right. So if we're drawing a vector towards the center, then taking the perpendicular right, how would that be for something like this? Well, it goes that way, then it goes to the right. Yeah, so that doesn't work. So what we could do is just flip if the x-axis if the x, see, in this case here, this pixel right up here in the corner will always go that way, right? And then you would sort of take the neighbor one to the right, and that's where you're always going to get a bad result there. So I think we might have to do the wrapping code. Hey Kept Payne, welcome back. How are you doing? 16 months, amazing. Appreciate the sub. It's time for that sub. Wish you the best, mate, sir. Haven't been tuning in as much, but still pop by and see what's up. Awesome. Thank you, sir. Appreciate the sub. Appreciate your support for all this time. Yeah, things are going well. Just working on materials. Have you seen all the amazing materials? I can give you a quick tour. Why did I just close it? I shouldn't have closed it. I didn't need to close it. So we got this sort of fractal noise generator, and for crying out loud, it broke. Right, that'll work. I loaded the wrong material shader. Boom. Lava. I had a better looking one, to be honest. The frame rate's tanked because it's generating it every frame. Let's look at performance. Right. Sorry, it just does it in 30 FPS. No worries. Yeah, so we had a nice looking one because we applied this sort of simplex noise on top, but yeah, it's alright, didn't it? Some nice emissive. It was made in code, but we'll be able to make it in with pure UI in a bit. So this is another one we made. It's all using the same shader, just the different virtual machine inputs. This kind of looks like hair in a way. It's blending two different normals together. Well, okay, it's running about 15 FPS. It's alright. Generates a 4K texture. It blends two different materials, different noises together and generates that. I think I'm probably lagging as well. Let's change it quick before the stream lags out. I'm probably really slow right now. This is me blending two different materials together, like completely different colored materials together, two layers. And then this is me trying out metal and scratching, adding like a scratched roughness to it. And we're trying to fix the normals right now. Yeah, adding like a roughness layer on top. But yeah, it's pretty cool. Quite happy with it. We'll be making a full UI for it in a bit. Well, the next couple of months. Hey 10x developer, welcome sir. Did you manage to apply the texture on a sphere without any seam? Yes. The only problem I have... Yeah, I'm using the octahedral map. Yeah, that's right. The only problem I have is I think I'm doing a mirrored repeat on one of the edges. So if you have a texture like this, you see a bit of aliasing going on. Yeah. But I think if we texture it properly, I don't think it actually shows up, the aliasing. And so let's see, does the aliasing still there? I can't really make it out, you see. So then we have to solve it. I'm just doing a mirrored repeat and it just reuses the same pixel basically. So it's a bit, it's not really that smooth. But you don't really notice it unless you've got an actual edge that goes directly across the middle. So I think it's fine. But yeah, it's using the octahedral map. Yeah, so we're just trying to figure out right now is we've probably got to do an octahedral map wrap. See if someone's written any code for that. I remember seeing that someone had some code for it, but I didn't really follow it. Right, that's not the with edge mirroring. Wrap octahedral coordinates. Oh my days. Someone's written some code. This is interesting. This is a bit bananas. So this is where it checks to see if it's at the boundary, basically. Wait. UV is less than... It's a manual bilinear interpolation. Interesting. Right. So apparently this is the code. Yoink. So let's try it out. So we should just be able to wrap. Yeah, I guess we can debug draw some of this, maybe. Yeah, okay. So just got to figure out what's going on. So octahedral map wrap. So we take a coordinate. So we take a coordinate and the dimensions of the texture. Right, let's massage this code a bit. Right, so it's texel, which was going to be ucoord. And text size, which is going to be dims. Alright, we're good. So, it's doing like a mod. Then an add. And then another mod. Why would it do that? Why would it do such madness? Because the first mod... Why is the second one needed? The first mod will just get you in there. Why do you need to add... And then when you add it again... Yeah, it doesn't make any sense. Pretty sure it doesn't make any sense. That line there is just weird. Let's see if there's another example. I remember there being an octahedral shader toy. I remember seeing one shader toy. Mapping and padding. Border expand, border contract. Yeah, they did it with an extra border. With padded border allows filtering map and atlas tiling. Oh, that's true. Maybe when you downsample, would you need a bit more of a wider... Huh. Yeah, Atlas clamps bitmaps is very, very wasteful endeavor. Yeah, you won't want to use this technique with high resolution probes. It becomes too wasteful. This is ready for convoluted specular probes. I found a sweet spot with a high where quality is equivalent to 256 by 256 by 6 cube map. Maybe even better, and the memory footprint is smaller than a cube map. Awesome. Oh. Yeah, so I'm thinking like, when we've got our mip maps and we're downsampling them, it probably doesn't matter. I think it's probably fine. We'll have a look. I haven't noticed any problems. I thought I fixed them all. Anyway, let's take a look at what it's doing here. Yeah, I wonder what's... Right. Yeah, this is not useful, I don't think. No. Yeah, this is one we're looking at. Okay. Let's go back to porting this code over. So... Right, so it's an ABS F32. Right. Boolean casted into an int, which we don't have to do. Let's cast it into a float regardless. We don't have to do that technically. Rather than your XOR in it. Then and one. Right. And then that either gets you dims subtracted with add s wrapped with 1. And if not, you just return wrapped. Okay, let's give that a go. So replacing these with... So how can we debug to see if this works or not? So what we can do is try... And what can we try? We could try... There is a coordinate in the... How far can we zoom in the texture viewer? Because in the texture viewer, we do have the coordinate that we're hovering over in the texture. So we could zoom in on a pixel maybe, and then zoom out, and then maybe see where it gets mirrored to, perhaps. Might be a way to debug, see if it works. So, oh yeah, but we zoom, we won't be able to hold it in on a pixel. So maybe not. Yeah, we want to be able to test the wrapping. I guess let's just pick right, so we're going to disable that debug drawer for a moment of that big red thing here. Then what I would like to do is try a sort of this wrap here and produce. So I think what I would like is to take this code just above here like that. Then I would like to take this code here, which computes the y coordinate and then run it through. Be really careful with this. How do I make it such that it's... maybe we can do it. We want to make it so there's only one pixel. Or maybe we can move it back to... move the normal back into UV space. And then move it back into a... pack octahedral. For this debug normal. Then I guess it's this sort of test UV. And then with the test UV, we can bring that into a test pixel, which would be a sort of a subtract. It'd be a multiply. Okay, I think we got it. So it's a subtract to the end. Well, at the end it's probably a E32 cast, but it's definitely a... Wait, do we want it in UV space? What does that code do above? Oh, it's a pixel, isn't it? Gotcha. Oh crap, this needs to be signed. Right. And also, why are these... floating point? Yeah, right. So it's probably ABS signed, isn't it? And then you wanted that to be casted into an int, which you don't need in C. Okay. Right, that's better. Okay, so I wanted to build that sort of... So it's a multiply... Wait, it was a subtract to the end of it by 0.5. But we need to first multiply by the dimensions. So it's TUV multiplied with this bit up here, then subtract 0.5, and then cast that into a, probably the assigned one, let's say. Now, what I think we can do is say, right, if all of these are equal, TP is the test point and the coordinate. So that comes from a debug normal that we're going to hover over the mouse. So if we're hovering over that exact pixel, then do all of this code, which is going to get the neighboring pixels and, well, no, I think what we're trying to say is, like, if we are part of, you know, maybe we should do this code all the time. But if we are equal to this one, I want to color it red. If we are equal to the, wait a minute, what are we doing? Test pixel ucoord, test pixel, right. If x coordinate, so that's the sort of test pixel for x coordinate, that's the neighboring one, we'll color it like green or something, and the y one will color it blue. So this should be a nice debug for those neighboring pixels, and we should be able to see how it wraps around and then re-enable this thing down here, which will allow us to visualize that circle and see if it wraps properly. So let's just see if this works. Oh, this is difficult when doing plain colors like this. We'll find a particular edge where it's not a problem, I guess. Crap. Right. S. What the crap happened here? Right, center equals dims. Is there nothing called dims? Right. So that should be in the constants. Okay, so that should... No. There should be it. Alright, so hopefully this octaedral wrap works. Let's see. Right, so I'm not seeing anything, probably because it's a pixel and it's on the mouse. So we're not really going to see it on the sphere itself, but in the texture we should be able to see something. Doesn't look like it, does it? It's around the blue. I was supposed to see something on this cyan blue here, but I'm not. Yeah, I'm not seeing anything there. Right, that's not even running then. Do we cast it into an int? Yeah, we do. It's an int, obviously, isn't it? So multiply by the... So you're scaling it up, taking away 0.5. I don't understand why that wouldn't work. If all is equal, make it red. I wonder what it is. So we can print it out. I can do a print. And we'll see why. So if is mouse at equal, we'll do a print of TP, and we'll hopefully see why this is not rendering. Right, so we're seeing TP out here in the terminal now, and we are seeing that, you know, this is about 800 odd on the X and about 2000 on the Y. So we see in the texture viewer what that looks like. Yeah, 800 on the X and about 2000 on the Y is around here. Oh, I can see pixels. I see pixels on the black area. There. Amazing. Right, there we go. We get some neighboring pixels there. That looks alright, actually. Now, what I need to test is like, do they wrap around the edge properly? Red, green. The problem is the red one's not going to map well. Maybe I just need to hard code it so we can actually just see it. Yeah, so we'll say if you're... So we'll hard code a test pixel coordinate. I think this is what we want. Something like that. What is that in? Right, 0, just 0 on the Y, obviously, at anything. Right, 411, okay. So why don't we try that out? So we hard code it. So it was 411, 0 on the Y. Right, now it's not tied to the mouse coordinate anymore. And instead of using red, we've got to use something different. So we'll do that. And then it should be visible on black and red. So that's recompiled. Now it's hard coded, okay? So I'm not really seeing it over the other side here. But let's open up the texture viewer. So this is the pixels here. We're definitely seeing two of them. Seeing the yellow one, which is the one we changed from red, so that's yellow, blue. Now there should be a green one. over here somewhere. It seems like that wrapping code's not correct. I wonder where the green one has gone. It would be nice to know where that is. So luckily we can find out with this. So red. Oh yeah, yellow, green. So I want to know like... So X coordinate. Let's see where that is. Let's go to the crap. Whoopsie, that broke. Right, let's run that again. Hopefully we see a reasonable coordinate. Right, it's just got -1. It's clearly not wrapping, is it? So that's because... Oh, we've not even ran it through the wrap function. There's one thing about it. So we didn't even run it through the wrap function. Whoops. So yeah, I want to take, say, x coord equal wrap x coordinate with dims. Bear in mind that's got to be casted into a signed signed vector, and then we'll wrap the y. Right, let's try that one out. What do we see now? Oh, that looks like a good value actually. See it in the texture. It's just along the x-axis, which seems correct. Right, so here's these guys here. You got the pixel we're sampling, the neighboring one along the y-axis. So it's gone towards the middle, and the x-axis one's gone off, and it should be over here. Don't see anywhere. It says it's at 3000 though. Oh. What crap happened there? Right, 3000. I've got it here at the coordinates. I don't see a debug printing out 83. Should be right here. I don't see it. Why is that? They should always be the same. This should happen. We should see a green pixel. Right, let's move it into. So here we're saying if. Yeah, so I guess let's make it such the mouse, when the mouse is at that, we'll print this out. So we only print that out if the mouse is on that pixel coordinate. So it's not printing out anymore. 8.3, I think it was. Right, it should be printing out there, it's not. I think it said it was 8.3. Three, 6, 8.3. Should be right there. Right, so this if statement is not hitting for some reason. And it's a bit weird. So let's print out the U coordinate as well. So that'd be U and U. Something very weird is going on. Expect that to work. Oh. Why is the Y coordinate? That's not good. Right, so it seems like my... Oh, it's Morton Swizzled, isn't it? You bugger. Do I want to Morton Swizzle it? Oh, no. The Morton Swizzle shouldn't matter. Oh, right, I'm getting a bit confused. I'm saying is mouse at. That's obviously going to be in screen space. Right. But yeah, so this is obviously in texture space, and this is just expecting it to be at screen space. So, okay. Why isn't this firing though? That's bizarre. So this should fire. Because we're printing this out. And it's putting out those coordinates, but is this different across? So it's hard coded here. F chord would be the middle of the screen, right? I see. So they'll have a different neighbor. Would it? Oh, U chord here should be the test chord pixel. Right, okay, that was it. Wrong. Okay. Right, I think we're gonna get it working now. There we go. We see it. the green pixel. We shall celebrate. So this means that it's wrapping properly. So the original coordinate is over here. And this yellow one's the original coordinate. The blue one is the neighboring y. Yeah, the neighboring y coordinate. So 1 pixel along the y, going up the y towards the middle of towards the top pole of this sphere in octahedral space. Then the neighboring x, so the perpendicular to the right x, is appearing here, which is correct, the way octahedral maps work and wrap around. Cool. So the next thing to look at is just trying the other edges to make sure they work. And then we can test out the normal map code that we've written with this new wrapping stuff. So let's just double check, right? Let's put this back on. So the next edge I want to test is, so probably these edges here, right? This side. So that is red going into black. So here, right? This edge here. Oh wait, I've already done that. So red going into yellow. Here. So it's in texture space. Yeah, it will map from that right edge and it should appear over here. Okay. So that is testing something far to the right. So that would be, our test position would be at 384. Oh, what is 4K again? Got it here, isn't it? Oh, okay, so it's right, okay, so it's not that 4K, it's proper 4K. So 1 off 4K along the X. And let's just put it somewhere 800 down, something like that. So try that. So we've got a red, so we can't use a yellow or red color. So let's use a white pixel to test. Oh, and then we want to disable the, oh, it should be right. Okay, so what we're looking for is some random colors on the edge here. We cannot see any. Ah, here we go. Right, there's 1 pixel there. What does that even mean? It shouldn't be that color, should it? So that one is 800. Up. Right, let's bring it in by 1 more. Now we're seeing 2. Showing up as purple for some reason. Let's do another one. What the crap is going on here? Okay, it moved. Right, this doesn't look good. So we've got this sort of test position. Where is it? Center position. We're taking that test pixel, which I guess is that white one. And then Drawing a vector towards the center, taking the sign of that, so it gives you probably minus x, positive y, I imagine. We can definitely print all of those out, to be honest. Don't know why I haven't done that. And the other one was TP, which is that test pixel. So they should all be next to each other, basically, just off by one, kind of diagonally. Oh, that might not work. It's fine. Okay, so apparently they're all there. Oh crap, I'm viewing it in the MIP, downscaled MIP, that's why. Okay, here they are. There is our little mouse, if you're gonna call it that. Just like a mouse. Pixel mouse. So yeah, so we'll, okay, so we move it back to the right to this 5 here. Right, there you go. So you got one off the edge, and we should see the green up on the yellow, basically. Here it is. Right, that wrapping works. We saw it. I lost it now, though. There it is. There we go. All right. So that works that side, which is cool. There's another one, which is the... So we've tested it at a 0 edge and an all positive edge as well. Let's bring the X down to 0. Now the problem is we've got to get rid of a green color. And green, so do that. Cool. So looking out for some pixels on this. Alright, where are the pixels? Zero along the X, 800 along the Y. Oh, so apparently they're in the black area. Here they are. Okay, so they're not quite off the screen because they didn't need to. Yeah, they didn't need to do that. So the one to test would be if we put them up a bit higher to, I think, 3,800, let's say. The perpendicular right should come off and it should appear somewhere. Here you go. So this is the one which went off and wrapped around. And then here's the ones up here. Here we go. Cool. So I think this is good code. So we've got a way to wrap a pixel which goes off the edge of a octahedral map. So that means now we should be able to fully correct that. Oh, that was a long piece of work to do. But yeah, so these are the functions basically. So let's just take these, go back down to here. This is our normal map from high map. We just got to get the, put this in here, octahedral map wrap, and it will wrap. Let's put it back here. So it's going to take, so I didn't really change any of this code, I remember. So just in case it goes outside the boundaries of the texture, wrap it back around respecting the octahedral map, and then sample the neighboring heights. Okay. Right, so now it's got to plug in this material here, and then that should update the normal map. So let's go give it a go. I'm just going to go and quickly put that back to texture material 2. So go into the graphics. Okay, so we won't run this every frame anymore. And what I also need to do is generate another pass. We need to run pass 1 as well. And that generates the height map. Cool, so let's give this a run and hopefully we see a... Oh. Hang on a minute. These need to be signed. That was something we did change. So these will need to be E32 cast. Yep. Okay, so hopefully that should be the normal map being generated correctly. We'll have to eyeball it a bit, I think. Right. So we take a look at the normal map now. How does it look? The roughness is being applied on top, isn't it? Let's take the roughness layer off. It's very hard to tell what's going on. Let's just see the metal layer. So we can do that actually. I've got hotcode reload going, so we can just... Let's go to the instructions. So it's this material here. We only care about the Veroni and the grad, not the simplex, which is then applies the roughness layer on top. So let's bring that down to 3 instructions. And that will run this shader again. Right. So we're definitely just seeing the material thing, but I don't know if the normals are changed. I'm still seeing the... What sort of roughness we got? Oh yeah, we got no roughness, right? And metal. Oh, interesting. That looks quite interesting. So we're seeing that sort of Veroni. This is the normal map. It's in... it's looking very pixely though. The problem is that it's an octahedral map. So what we can do now is we could say, right, I don't think I'm taking the normal and shading with that new normal in the PBR shader. That might be it. Take a look. Yeah, we're seeing lots of these rings though. This is a bit questionable. These are... But yeah, it is kind of following the Veroni though. So it seems like it's partly working. Which is interesting. So the next thing to do would be to take a look at the calculate surface color. Now in calculate surface color, we have not sampled the normal by the looks of it. Interesting. So let's sample the normal, and we might see some of these patterns show up in the... right. So the material cache, I think that's in shared internal. Right, we're not doing this one. So normal sample. Right, so it's unpack octahedral, because that's where it's packed. We sample the normal at with the material LOD. Oh crap. Yeah, so this gets the texture at this material LOD. Then we're sampling using MIP gradient. And using that sampler with DDX, DDY. Right. So with that normal, what can we do with it? So there is a surface normal in world space. We haven't necessarily got a way to bring it out into... We need a way to overwrite it, that's the problem. So we might need a... We could bring everything into the local space of the object, or bring the normal back out into world space, basically. Just wonder what we should do. So these are all in world space. Well, these two are in world space. So if we bring view direction and surface position in world space. Problem is there's all the scaling in that though going on. Right, let's just pass in a matrix for now. So this will be that sort of world from local. It's something we've got to mess around with, but we haven't got it working yet. So right, so I think we can then change shading dot surface normal to be the multiply of a vector. Yeah, but don't you want to do that attribute, yeah, matrix thing, isn't it? No, let's not do this. Let's make it all into local space. Right, so we're not passing in a transform. Yeah, this shouldn't be too hard to do. Right, so we're not passing a transform, we're only passing in local space coordinates, and that'll be okay. Kind of normalized. Will be scaled though. Yeah, okay, so that's less parameters there at least, which is good. Hey there, Plexom. How's it going? It's been a while. Where you been? How you been doing? How's it been going, sir? Right, so I think we can then just change shading dot surface normal local space to be that, which would be bananas. So that would mean this is all local space, local space, local space. And then in this light side of things as well. All right. And then these to the local space ones. Okay, that will work. Right, so we just have to be careful. We just have to now change all the places which use shading, the shading strut. So that's the BVH code, which is dead anyway, so it doesn't work. So local space, which would be the negate of ray direction LS. Have I got that? Then I need hit position, local space, yes. And then I probably won't need some of these actually. Now I'm doing it in local space. Doing good. Uni was really stressful until some weeks ago. Finally done with semester. Awesome. Well done. That's cool. Yeah, not doing bad, thank you. Very busy. A little bit tired. But doing alright. Yeah, you know, it's March, so the sun's coming out a bit now, so we're not just going to be in the gloomy, dark winter soon. So it's quite exciting. Yeah, my son is walking now. He's walking all by himself, like properly. So it's a lot of fun lately. And I have just completed Astrobot and done 4 out of 5 of the worlds, I think it is. I think it's 5 of the worlds. Or not worlds, the solar systems. I've gathered all the bots and the puzzle pieces for those. Just got a few more to do. So, yeah, things are going good. My son also really likes playing Astrobot with me. And whenever we're in the front room now, he'll look at the TV and go, Astro. Because he wants me to play Astro. Yeah, it was one of his first words. It was Mum, Dad, no. I think he would say, and then like I think Astro is probably 4th or 5th. Because I would try and, I'll get him on my lap and we'll play some Astro. Like most Saturdays. Not all Saturdays. But that, yeah. Good fun. If you have any plans for now, Plexum? Now that semester's over, you've just been relaxing? Yes, I think we don't need to do this and move it back into world space anymore, which would be amazing. Because that would be less computation. Oh, that needs to go into world though. Right, but we don't need that. Interesting. Yeah, playing video games again. Been reading some books and on 3D rendering as well. Cool. Nice. You got any sort of projects you want to be working on for 3D rendering? And tell me an interesting game you've been playing. Right. So we don't need the world space one anymore. So that's one less sort of sets of cross products and multipliers and normalize. Pretty good. Oh, then we need to rename that to local space in it. Then oh, for crying out loud. That's local space, local space. Oh, well, that's bad. Which means I don't need all these extra variables. Which is beautiful. The problem is if you miss. Oh, it's the redirection. Yeah, do the cube map. Bam, awesome. Right, I think we're getting close now. Right, here's the final one. Got too many renderers. So no world space required. Alright. That'd have been a bug. Alright, let's give that a run. This should be the normal map all plugged in now. Right. Of course, put the coordinate in there. Shoot, I deleted that line, didn't I? Okay, I need to move that. I didn't delete the line. I need to move this into the local space of the object. Something like this. I'll do it. Mainly Counter-Strike 2. Amazing. I used to play the game a lot. I used to play by myself though. But you're playing with some friends. Cool. Projects. Not that much. Just learning about how 3D rendering works now. Awesome. Have you I recommend you I have recommended to you this before. But take a look at doing like if you're learning like OpenGL basically and or DirectX or whatever. and you've not learned how to do how the triangle rasterization works, what you can do as a fun project is, so I guess here's an example to look at, or there's also other ones as well. Maybe this one as well. Take a look at these. But the basic idea is build instead a software renderer, right? And you can build one by either using SDL2 and taking the pixel data and then up and just blitz, using SDL render just to sort of blip that to the screen. Or if you don't want to do all that sort of Windows setup stuff, the easiest thing to do would just be to render a PNG image out. Save that as PNG. But the advantage of doing a software renderer would be you get to essentially like learn how OpenGL and DirectX works by kind of implementing your own version, custom version of those APIs in a more far simpler way, and see sort of where pixel shaders fit in and where vertex shaders fit in into this sort of software render pipeline. And you can, all of the features that OpenGL and DirectX have, you can implement them in software to sort of get a feeling for how they work. And you'll have a much better and easier understanding of those APIs after you've done that, basically. Yeah, I keep forgetting Not So Red's project. I haven't seen Not So Red for a while. Was it Red 1? Not So Red. I'm not sure if it's still got it up there. He basically re-implemented a very simple version of Vulkan. His own version. Where he had like pipelines and vertex shaders, pixel shaders, and just sort of implemented some of the rasterizer state and even got PBR shading working all in software, made an image, and some meshes as well, through meshes in there. It was cool. Very cool. Yeah, highly recommend doing that first. Be far more easier as well. Bam, bam. Oh, you bugger, what's going on there? But how long have you been using Helix for? I don't know, 6 months? Something like that? Maybe? Oh my days, these normal maps are brickin'. But you can sort of see them working. Isn't that cool? You can see it's sort of raised. But yeah, it's a bit broken though. When we move, it's the MIP levels, right, that are... Wham, wham. But yeah, we've got to remove this pattern that we're seeing in the textures somehow. So we're going to fix that in just a second. In the meantime, I'm going to go and get a nice drink, but this is going to be amazing. This will add a lot more like detail and everything. It'll be cool. Right. BRB. Right, welcome back everybody. Right, so we've kind of got the normal map working, but it's not being generated correctly. We have these sort of weird artifacts, we're seeing that sort of 3D Veroni. But we've got sort of these like red, well the red artifacts coming from the fact that we're getting reflection from over there. It seems to be there's pixelation going on. Oh. Why am I seeing that rendered on top of my UI? I have no idea why it's happening. Bizarre. Right, so the normal is here. Can you see we've got this sort of look going on? So if we take a look. Yeah, it's just riddled. Right, so rather than just looking at the texture, let's see if we can debug visualize some of what's going on. So here's that function which generates the normal from a height map, and effectively we're just doing we're taking a sort of like a neighboring normal in the local space of the object, and yeah, let me just double check it all makes sense. So we're getting the center dead in the center, which would be the dimensions of the texture divided by 2, right? Then we're getting a sort of the middle of a pixel, so we're offset by 0.5. So this means that we should always get some value, and so we get a vector towards the center, pointing to the center of the image. Use this sign, so we get -1 or 1. We don't get 0, -1 or 1. Cast that into an int. Then cast that. Yeah, then get the perpendicular vector. That's all good. From the current coordinate, work out the neighboring x and y. That looks good. Then we do the wrap. Octahedral wrap. Sample the height. Well, not sample, load. Just the single pixel height. Then work out the UV. And then take those heights, scale the normal, unpack those UVs to get the normal, and scale them by the height. Now take the differences between the normals, the scaled normals, normalize the differences, take the cross product, and then normalize it again. Now, one thing that we could be doing, yeah, see, that seems okay. So I think what we should try and do is visualize these based on some hover location or something like that. Yes, just figuring out how to do that. So, we've got ways. I just want to double check the calculate surface color. That we don't do anything with this. So we use the normal to get the UV, and then after that, it's overwritten. So we just okay, go again. I think that seems okay. Wait a minute. let's not do anything with the UV and just make sure we didn't bust the... Let's not write it out. Let's make sure we just haven't ruined the shading code first. Okay, it's looking extremely pixelated, actually. Looks cool, though. But we're seeing the pixels. Oh, and we're seeing the seams. No. So this is part of the problem, maybe. Right, so maybe... Oh. So this seems to be okay, it's just there. I thought they would interpolate. Right, they need to... Let's see the... Yeah, we would expect it to be like this. Can't say 4K isn't enough, right? So what do we want to change? So we're using the right sampler. The sampler would be a mirror repeat linear sample. Yes, it should, yeah, do a bilinear. What is coordinate though? UV, material layer. Right, where it's stored basically. Which one of the materials is it? Okay. Yeah, that should all be... It's not bound to a particular pixel in any way. So I was expecting to see this... Maybe bilinear interpolation on a... It can't be. Bilinear interpolation was fine on the colors. You've seen the colors print out, render out just fine. We've seen it on the other ones. If I show the sort of lava material, for instance, we'll see Right, see, it's different material. Maybe it's just because this one, the other one's got reflections. We're seeing the seam now because of those normals. Yeah, those ones are not looking so bad, probably because they're rough, right? Whereas as soon as you need a bit of reflection. Right, let's take, yeah, look at that, it's horrible. Oh, right, so I think then, view space and the surface normal. Hmm. Yeah, I wonder what we can do to fix this. This looks like the wrong MIP level. Let's try hard coding MIP 0, see what's going on. Right, that crashed. Obviously. So yeah, I think because we moved it into local space, the... no. Ignore me. Yeah, I think maybe it could be that the MIP level is not the wrong MIP level. It's calculated and it's sampling a lower MIP. Right, I think that's looking better, but no, it's not. It's not looking better. How odd. If I get really close, the normals show up actually a bit better. Oh, what's going on? Maybe the normal values are... We could maybe visualize them. We could say if our... We could hover over them and get it to debug draw. A normal. But I wonder how useful that would be. I wonder if we need higher resolution texture and if that would solve it or not. But that would just be crazy if that was the solution. Is that we need a higher resolution, that would just be weird. See, back here they look alright. Although they are moving a bit. Seems like the MIPS. And it seems like these ones around the edge don't even work for some reason. Like if we swap out, let's comment out this line here, recompile. Right, it's just the seam went. Okay. Probably the do the Fresnel then maybe. Well, not the Fresnel, the what would it be? But yeah, okay, so it seems like yes, that's how it looks like normally. Then if we add in our normal map, which doesn't change anything, this is how it ends up looking. We see clear pixels, which we shouldn't, because it should lerp. Are we supposed to renormalize? Yeah, that won't really do anything, would it? Hmm. We should take a look at the sampler, but it does look like it is. Like if I was to show off that other material that we've got that we generate, it doesn't look pixelated. Right, it looks pixelated now because of that normal map. If we disable that, that pixelation goes away. Looks nice and smooth. Hmm. Yeah, just put that back and we've seen this sort of, we're just kind of seeing the pixels here again. And if we go back to that material, definitely see them here. But these don't seem like smooth pixels though. Right, that could be an idea of what's going on. So it just means that whenever we jump to the next pixel, the normal is really different maybe. Right, so we get the UV by adding 0.5 and dividing by dims. So it's in the center of the pixel. Then when we save it out, save out the normal map at least, we're just storing the UV in there. And that should work, because if you take a UV and then you unpack an octahedral map UV and turn that into a normal, it will just get you your normal. It does say unorm. Unorm will be fine. Unorm is what you want. It's 8.8 unorm. So that's probably where the problem is coming from. It needs to be. So what's happening is when it's serializing out to the texture, it's getting compressed into 16 bits, and that's where we're seeing this coming. Okay. Right. So we did 16 unorm. Right, that's probably it. Let's try that out. We just gotta do a bit of a rework. So that'll be where are we seeing this? There's the normal. So that's 16 unorm. I'll change that in my documentation as well. Okay, and then there's this is when we're filling in valid. In cube map, it's nothing to do with that. Right, the other one was in the calculate surface color. There is a right, okay, it's no biggie. Let's go to the graphics side now. 8.8 unorm, so that's 16 unorm for the normal. And then again, here's another one. Ah, right, I think we might have found the problem. So the other one is then probably in the material plan. We're writing them out as 16 unorm. 16. Gotta update that for emissive anyway. Alright, let's just run that and see if that works. Ah, my mistake. Was it 2951? Right. We didn't update it in the it's more than just the fill invalid. Where's that test material? Here it is. Beautiful. Alright, let's try that out. See, we're getting some banding, if you will. I think that's what's going on. Right, now we're seeing the texture that we shouldn't be seeing yet. This is one that's got different problems. I decided to, before investigating this problem, see how it would look if we just there we go. That's better. Awesome. Yeah, so how does it look if we just displayed the default normals before we changed them? Cool. So let's go ahead and quickly comment out the code where it changes the surface normal for the one in the texture in the calculate surface color. So we change that now. Right, I see no difference in quality. That just seems to be, this just makes sense. This is just how the pre-filtered map looks. And we're not getting this close anyway. Right. That's cool. So we can live with that. We're getting some weird edges here though. What's that about? Oh, that's just the shading of the color. I think that's just the color of the material. So it's like actual black pixels maybe. No, it can't be that. Because it's... Forget how these things work. Yeah, it doesn't look black to me. Yeah, I wonder what's going on there. There's the height. Roughness and metalness is red. Yeah, metalness is a red channel. So yeah, I wonder why this disappears here. Let's try monkeying around with some of the material settings and see what's going on there. So this is the calculate, this is when we sample the material actually, so why don't we set albedo in this case to 0.5 all the way around. Now the question is that a... Right, okay, that should do it. Like a grey. Right, so we're still seeing some problems with that. It's a clear cut. I don't know where that's coming from. We could put the height map back on. Could we? Let's try emissive out as well. Let's put that down to the same sort of thing. Right, that still has that sort of weird seam there. So my next thing would be, let's hard code metal to 1 and roughness to 0. Seems to be the same. So if we change the material, let's say we didn't make it metal anymore. Where was it? Submaterial 3. It's the next one. So we didn't make it metal. Do we see any sort of edges, outlines? Sorry. So we add roughness. That's what I meant to say. Right. I wonder if it's to do with because we've moved it. I wonder if we need to normalize the view. But these are no longer maybe normalized. Yeah, I reckon, right? Let's go to the shading one. Is this it? I think this is it. And then we normalize that. Does that help anything? That's much better. Pretty sure. But have I got rid of the metal or something like that? Yeah, so I need to normalize my view direction local space. The problem is this ray direction is not normalized anymore. It's scaled. Yeah, it's a bit weird. That's fine for rays. It's not fine for... It's not okay for this view direction thing. I think it's not fine. I have to double check actually. So the hit normal as well. Yeah, that should be alright. Okay. So the thing I want to double check is this ray direction. How are we using it in the surface color? Right. Calculate surface color. So we're doing this sort of like plane. We're putting sort of a plane and we're calculating the DDX and DDY by seeing the distance between your neighboring pixels which are hitting the plane. So there's like a plane which goes perpendicular to the... Imagine pushing out a plane such that it goes through the middle of this sphere, and we're getting the rays along that, the neighboring rays along the Y and the X axis. So we're talking about the ray direction in terms of that, seeing it with the dot product. Maybe those should be normalized as well. No, but if they are, then it won't respect an ellipsoid. Maybe. Yeah, well, I'll think about it some other time. But yeah, right. This definitely normalize though that view direction though. View direction, local space. This definitely needs to be normalized. And that'll fix our sort of thing we are seeing with the default. Cool. There we go. Right. So I guess if this was brighter, you would see more of the reflection maybe. That's cool. Right, so we put the normal back on. The modified normal. It's still got these sort of glitches. on it, but it's, yeah. But at least we know the default one works. Oh, yeah, so the default normal works fine now. We can see the reflection. Maybe can we change it to be a bit more plasticky with that? We can add the roughness layer on as well, actually, and see that. That'd be interesting. So anyway, where's the plastic? Let's make it plastic. So metal is 0. Right. Yeah, so we're seeing the reflections here. That building is that one there. We're seeing these lights. Guess that makes some sense. Okay. Maybe the reflections are a bit off. I don't know what's... They're in local space, aren't they? Oh, we're gonna move back into the world, isn't it? Because that samples the pre-filter map. Yeah, now these are in local space. Which means we will need a world from local transform. To sample the... Yeah. Well, it's been fun. Gonna go now. Have a good one. Thank you for popping by, Plexum. Have a good one. Good to see you. Hope you have a good rest of your week. Yeah, so this reflection sample is not correct. We have to pass in a... Awesome, thank you so much. Yeah, we have to... That's in local space. We already need it world space. So I guess let's get that one in there. So that'd be like a mol vector matrix shading world from local. And then you pass in the vector, which would be reflect direction local space. Now this will probably have scaling on it, so we probably need to renormalize that. And then we need to actually go ahead and pass that in all the different ones. So we will need matrix 3D from local. And we'll need to make sure on every one there's shading. Passes, we do pass that in. So that's the BVH one, we don't do that anymore. Right, shading dot world from local equal world from ellipsoid in this case. So matrix, good. Next one. World from ellipsoid, we've got that in there, good. Crap. Right, I need to do that inverse thing as well. So unfortunately this one hasn't done it yet, so that'll be an extra cost to this shader. Right, it's in there now. Good. This one has it, which is great. Right, that's the... Right, I think we made it full circle. So if we try that out now, we should see proper reflections. They should go in the right direction, basically. if it compiles properly. Right, I forgot to use the world space vector there. Let's give that a go. It seems like it's okay, although I cannot tell based on... I need to bring up the brightness of this a bit, I think. Or can I make it be plastic again? Oh, it already is plastic, is it? Well, if we go back to where we were, we could probably scale the reflected radiance up by some fixed value. Let's say 5 might be enough. Might be able to see the background a bit more. There we go. Right, so we are seeing there is this sort of gold thing there, which is there, yep. And then back there it's more black with like... Okay, so that seems like it's the correct reflection now. Right, so that sort of building behind us here. There we are. Yep. Nice. Good, 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 good. Alright, I'm glad we fixed that. Okay, so the other thing was go back to that material and make it metal again. Because that's the way it was. And now I would like to... What do I want to do with it? Should look at those normals again, isn't it? Yeah, let's put the roughness back on. I think it was 6. Yeah, 6 instructions. That puts the roughness layer on. I have the roughness layer. I don't know, the normals seem fine, I guess. In terms of like, they don't seem to be interrupted. Let's take a look at the normal map. Oh crap, I didn't... Okay, it's not got the texture on top. Right, so yeah, I uncommented the pass, which encodes the new normals based on the height map. So we'll try this one out now. Is there any clear... Okay, there's some clear problems with this one. Okay. Those normals are really messed up. Damn it. And it's for some reason renders on top. Don't know what's going on there. Anyway, but yeah, so this is what it ends up looking like. I guess this is too much of an extreme example. The right, so we just see this normal map. We're still getting issues with this one. So this is without the roughness layer on top. What's being also generated is this. It kind of looks alright. It's just we're getting lots of this sort of banding still. Could that be from the height is only 8 bits? There might be because the height is only 8 bits. And it's unorm. No, unorm is fine, isn't it? Yeah, I think that's the problem. If we made the height 16 bits, that might be enough. I still don't know what's going on here with this. Whoopsie. But, right, here's the height texture. Let's get out of the way of that. So we are seeing this sort of banding here. Maybe. Yeah, that's banding to me, isn't it? So that's probably what's causing... Now we go to the normal map. Yeah, that just seems it to me. So if we up the resolution of the height map, so we'll go around and do that one quick. So that's 8 unorm. Just got to change in all those places where it's doing its 8 unorm. I don't think we use that one anymore. We should really call this height. Let's go back to the material plan. Oh, roughness. Okay, we need to add another one. So we'll call it roughness and metal at 8 unorm, but height is going to be in 16 unorm. So what I would probably want to is copy paste this. So this is just a downsampler. Did I do a normal on the... Yeah, renormalize after doing a mean. Yeah, that'll probably work. Right, so we copy pasted this. This is 16 unorm downsample. 16. 16, 16. Right, that seems good. Just keep looking around for these. Here's an 8 unorm. Here's another one. And this is when it's loading from an 8 unorm. We do the auto generate. Cool, so inside the internal shared, there's also going to be another one. Case for it right here. And there'll be another one in the test material. Bundle constants will be uploaded to the shader. Nearly there. So inside the graphics now, there'll be a few places. So the actual height map materials themselves need to be updated to 16. And then probably there's a downsample pass. Here we go. So this line here runs the AMD downsampler for 16 unorm now on... Turns out we didn't need the 8 unorm one. We'll go and delete that. Maybe I should just call it height. Right, so we go out to the shader. Well, let's make sure we've got all these. I think we have. Yeah. Oh no. Yeah, but shader or shaders. So rather than call it 16 unorm, we'll just call it height. Specifically for height, this is. Cool. Okay, so if we give that another run, that should fix our banding problems, hopefully, on the height, which would then hopefully fix the normal map being generated. It's looking better. Maybe this is right. To some degree. We're getting some weird outlines though. Yeah. Oh, maybe we're getting NANs. We're getting NANs in here, isn't it? Nan. That's why it's showing up in this buffer, because it's the way it's blending with an NAN. That makes a ton of sense now. Right. So those normals could be NAN. There'll be like a zero length normal, therefore causing that problem. Okay. Let's take a look at the... So the height looks better. Not as much banding anymore. There is a slight band though. We could just do 32. We could just do 32 height, to be honest. I don't know what the problem would be. 32 bits. But yeah, that does look a lot better though. And then the normal, this is it here. That is looking a lot nicer. This is a bit weird over here. What is that like in the height? Oh, okay. Bit odd, isn't it? Oh no, sorry, it's not it. It's this one here. Hmm. This is a bit weird. There's no weird pixel pattern in the height though. Or we can change the range here. Looks alright to me. Yeah, some of it does look alright. But I'm not seeing any blue. And this is meant to go around the whole of a sphere. So that's another sort of red flag. Yeah. Okay, so that is the red flag for this, at least. We're not seeing any... Oh no, no, you wouldn't see any blue. This is only just a red-green texture, isn't it? It's a two-tone it's a two-channel texture that then gets unfolded into a three-channel. It's an octahedral map, isn't it? Right, so it should basically be red over here, and then going up, it goes to green. So over here it should be yellow. So if you're seeing yellows, I don't know, it's hard to really work out. But yes, it looks painfully wrong to some degree, so we should probably try and debug the normals by debug drawing like a line based on what we're hovering over. Okay, so I think that's a good place to put it. So at least we're able to sample from a cube, from these. yeah, sample from these normal maps, but generating the normal map is still off. So we just got to, from the height, so just got to figure out how we can do that properly on the sphere. And then after that, there's going to be a seam problem. There's problems with seams, so we might have to correctly handle seams in our shader code, unfortunately. But yeah. Okay. Right, so let's just pack that up. Find someone to raid. In the meantime, there's a Discord channel if you want to come hang out and chat. The next stream will be on Thursday, about 3.5 hours ago, but on no, about 3 hours ago on Thursday. Yeah. Then if not on Sunday, there'll be a nice stream as well. So hopefully next stream we'll get the normal maps all sorted out. Then very Valigo. Cool guys. Alright, have a good rest of the evening and I'll see you all in the future one. Bye.